Hello everyone. Uh, we welcome you all for today's webinar. A very good morning, good afternoon, wherever you are. Yes, yeah, sorry, there was some adjustment I need to do. Yeah, a warm welcome to all of you. And myself, Anandan Subramaniam from Asia Leads Partnership, which is hosted by ICLI South Asia. And I'm supporting to manage the secretariat services of the partnership. Today's webinar will focus on financing solutions for improved building efficiency in cities. So this is actually the fourth webinar in the webinar series organized under the Building Energy Efficiency Communities of Practice. So the initial first three webinars focused on improving energy efficiency, especially in cities through policies, technologies and solutions and financing solutions. Um, yeah, can you move to the next slide, Ritvik? Yes, I'm sorry, this webinar will focus on benchmarking to enable building energy efficiency in cities. So here is the agenda for today's presentation. The first presentation will be by Dr. Saket from PS Collective. He will present on overview of benchmarking to enable building energy performance improvements at scale. The next presentation is by Caroline from Berkeley National Laboratory, who will present on building energy performance benchmarking experience from the Asia region. And we have speakers from WRA India and ICLI South Asia, who will present on energy benchmarking case studies from Kochi and Nagpur city from India. This will be followed by a Q&A session and information about next steps. Next slide, please. Yeah, a quick recap of building energy efficiency communities of practice activities. So this BE Corp was actually launched by Building Efficiency Accelerator and the Asia Leads Partnership in 2019. So the communities of practice brings about capacity building and supports sustained and focused learning, and it gives access to tools and resource materials. Based on the members' need, the webinar topics are selected and relevant tools and materials are shared with members. A quick intro about Asia Leads Partnership. It's a voluntary regional network that promotes low emission development strategies in the Asia and Pacific region. LP facilitates coordination, collaboration, and fosters partnership between organizations. It brings about capacity building, such as organizing these online sessions. So similar to this building energy efficiency communities of practice, Asia Leads Partnership also manages other communities of practice on various thematic areas such as transport, finance, energy, focusing on storage and power sector transformation. And we would like to bring to your notice that Asia Leads Partnership offers free of cost short-term technical assistance to developing countries through climate help desk services. If anyone is interested to avail such technical assistance support on energy efficiency topics discussed today or on other NDC or low emission development strategies, please write to us. And about Building Efficiency Accelerator Initiative, it is one of the 6 efficiency accelerators established in 2014 under Sustainable Energy for All. BA is led by WRA Ross Center's Building Initiative. And we would also like to bring to your attention the opportunities available for subnational governments through BEA initiative. So just some benefits are listed. It advises on assessing and prioritizing locally appropriate actions and policies. It provides a range of tools, expertise, and solutions, and supports in fund mobilization and offers international recognition and collaboration. If anyone is interested to specifically join the BE initiative, you can please write to us. Next slide, please. Yeah, we have a panel of eminent speakers with us for today's session. The first speaker is Dr. Saket Saraf, who is the founder and principal at PS Collective, which is a platform for advocacy, research and policy analysis and consultancy. He's an architect and has been part of various building energy performance benchmarking initiatives in India for almost more than a decade. We welcome Dr. Saket. Next, we have Caroline Scumph, who is the program manager at Lawrence Berkeley National Laboratory. She has more than 17 years of experience in energy efficiency market transformation in North America and Asia. She also leads research and development of the better tool that's very new, and she'll share further information about that today, and plays very active role in several other energy efficiency initiatives around the world, especially in Asia, also in Southeast Asia. Warm welcome, Caroline. We have Dilan. He is working as a senior project associate for energy program at WRA India. Dilan has been working in research oriented and several consultancy level related projects related to energy efficiency measures. Welcome, Dilan. So finally, we have Nikhil, who is my colleague at ICLEI South Asia. He is a manager in energy and climate team in ICLEI South Asia. Under this Asia Leads partnership, he supports the building energy efficiency and grid renewable energy communities of practice. Through various projects, he has supported assessment, planning, and implementation of energy efficiency solutions in many Asian cities. He will also help co-moderate today's webinar. Before we actually move on, may I now invite Nikhil to inform the housekeeping rules for today. Thank you. Nikhil, over to you.
Yeah, thank you, Anandan. A warm welcome to everyone again. We're glad to have you with us here on this webinar on benchmarking. Yeah, a few housekeeping rules before we start. So please note that all of you, all participants will be on mute through the webinar, and we are switching around the agenda a bit. We will to make the session more interactive. We will have a question and answer. We'll take a couple of questions at the end of each presentation. So for this, we would really like participants to also speak here, but if you could type in your questions and direct them to a speaker using the chat or the questions option, which would be there at the bottom of your interface, and you can send them in, and we'll take them up post each presentation. And anyway, at the end of all presentations, we again have an opportunity to interact further, and where we hope you can also share experiences related to benchmarking. Also during the Q&A, if you can type in your questions and raise your hand, so then we can facilitate interactions. And today's presentations are available under handouts. So for your viewing, you can also download these, please. We'll now get right into it since we have such an exciting lineup. And I will now invite Dr. Saket to deliver the opening presentation and give us an overview of why and how benchmarking is useful, and yeah, the modalities therein. Over to you, Dr. Saket. Yeah, Dr. Saket, you're on mute.
Okay, thank you.
Yeah.
Let me know when you can see my screen.
Yes, we are able to see your screen, Saket.
Okay, great. Okay,
Yeah.
Good morning, everyone, and good evening and good afternoon, depending on where you are. I understand that people are joining from all parts of the world today. So my name is Sakir. I've been associated with the benchmarking program in India for almost a decade now. So given this is the first presentation of the session, I would give you an overview of benchmarking, and in the second part, walk you through some of the ideas we have been toying around benchmarking at the city level. And then, of course, be happy to take questions and later on have discussions towards the end. Okay, so first let's talk about benchmarking in general. So give me a second. Yeah, so why benchmarking is a question that often comes to our mind, and if any of these questions are something that you think is relevant in the area you're operating in, benchmarking can be one of the tools that can help you address some of these questions. So if you commission a building from a designer, how do you know it is designed for efficiency? Or if you are using or managing a building, then how do you know whether it's being operated efficiently or not? Maybe the building is designed efficiently, but not operated efficiently, right? Similarly, how can you quickly estimate the saving potentials in a building? So you have a portfolio of buildings, but you want to know which of the buildings may have more low-hanging fruits for that matter, right? Or if you're entering into a real estate deal and you want to purchase an efficient building, how do you know in the first place whether the building is efficient or not, right? For governments, how can they know whether how can they certify whether the building is efficient or not? As owner, how do you track the performance of building over time? And how can answer to some of these questions really inform the design process itself? So go back to the design level and make sure that the building does what it is supposed to do over its lifetime. So benchmarking is a way by which you can compare similar things, and doing that fancy comparison, you'll be able to answer some of these questions. But the challenge is that all the buildings are very different. Different uses: so office, hospitals, hotels, shopping malls, different sizes, different operating hours. Some are like 1 shift, 2 shift, 24-hour buildings. A different number of users, different number of beds in hospitals, different number of rooms in a hotel. Varying climatic conditions. Some are naturally ventilated, some are fully conditioned. So the building stock is not a uniform thing. And the whole idea is, how do we start comparing these heterogeneous kind of buildings to still make sense and say a hotel with 50 rooms is more efficient than another hotel which is 200 rooms, right? So how do we kind of control for all these varying parameters and still be able to say whether the building is efficient or not, whether it's being operated efficiently or not, and where does the saving potential lie? So that's the challenge. So typically you kind of look at all the building parameters, put them in a kind of a nice statistical or a technical model, package it in a tool so that it becomes much more user friendly, and then start using this tool to answer some of the questions that I shared earlier. So this is an example of an online tool that was developed for India, for the Bureau of Energy Efficiency. You can enter your building characteristics. It tells you kind of a curve and tells you where you are in terms of a performance spectrum, and doing X, Y, Z would move you up and down this curve, and it gives you a star label at the end of the day in terms of how you're performing. There are many ways to benchmark buildings, and again, it depends on why you want to benchmark and what is your objective, whether you want to benchmark the performance using site energy or source energy. And this becomes very important, especially if you are doing a grid interactive building or there's a lot of renewable coming in. You can have scales by which you kind of label the building. It can be technical, statistical. You can benchmark a building against their peers, against itself over time, or against some absolute like net zero. right? You can use different kind of statistical, technical, building physics, expert opinion kind of models to benchmark. There's also something called a graduated approach that, and this is very applicable, especially in the Indian context where you may not have a lot of data about a lot of buildings. So can you have a graduated approach where you benchmark most of the buildings using some simple metric and commonly available data, but you also have a more complex model which allows you to do some more useful things that I think Carolyn will also talk about later on today. Then depending on your motivation, you can do a benchmark which kind of benchmarks the assets or benchmarks the operation of a building or benchmark the entire portfolio. You can do benchmarking for action. You can do benchmarking to track performance. You can do benchmarking to certify the efficiency of the building. You can do benchmarking to do a demand side management or a fault diagnostic or detection. So depending on what your motive is, what is your data set, you can choose a different approach to benchmarking that is really suited to your context rather than just importing a benchmarking model from somewhere. So benchmarking can be done at components level. You can benchmark bulbs and lighting fixtures. You can benchmark systems like the air conditioning systems in a building. You can benchmark the whole building. You can benchmark clusters, so a campus, a neighborhood, and now benchmarking cities and the building stocks in cities. So the benchmarking can happen at multiple scales and with multiple objectives, and a combination of these would help you guide to pick a right benchmarking strategy that will work for you. So this was an overview of benchmarking. I thought it would kind of help to put things in some perspective for those who are not familiar with benchmarking in general. So next, I will be talking about benchmarking at the city level. How can some of these be deployed at a scale of a city so that the combined benefit is much larger, the whole enterprise is much more scalable, and you can really track the performance of the entire building stock rather than just having few boutique green buildings spread here and there, scattered here and there, right? So the whole idea is to move from few buildings to the entire building stock. And another motivation for doing that is that mostly the energy policies are top down. The national government, the state government says, this is the national energy code, and a directive comes to the city to implement it, right? And at the bottom level, there's capacity constraint, there are implementation challenges, there's a mismatch. So the top-down policies may not always be very easy to implement at a city level. Of course, they also have high cost of compliance. They are based on intention-based code. So you do A, B, C, D, and the building would perform good on paper. But whether the building is performing well on ground or not is not really covered by those intention-based code. And then, of course, there's information asymmetry in the marketplace. There's no way to really value the energy efficiency in a real estate transition, and therefore there's not much incentive for developers to invest into it. And the $1 million question: there's always a lack of data, be it to support policy formulation, to implement, to monitor. So all these factors which kind of work against a very top-down approach are relatively well addressed in a bottom-up approach like benchmarking at the city level. I think I clicked on something.
We are able to see the screen.
Okay. It vanished from my screen. Okay, don't worry. So, so why cities? Okay, so why cities? If you do benchmarking at the city level, you can set goals and target for your cities, which is a very bottom-up consensus-based approach. You can prepare, plan, and implement and track the progress based on the targets you have set for your city. It helps you to very quickly recognize best practices. Use benchmarking at the city level as a carrot and stick approach. create a data ecosystem and not wait for some godsend data from top down based, but have a very local actionable data set that has much more credibility in the community. And it helps to link to other energy efficiency and sustainability programs, like say you need to do an environment impact assessment, you want to connect to some DSM programs, connect to PAT, connect to any kind of green funding, and of course spurs the green economy in the city. So we saw that there were some push factors from a top-down approach, and then there are some benefits if you do benchmarking at the city level, right? And it spurs the growth in the local economy, because benchmarking may allow you to identify energy savings opportunity, which I think the next presenter will cover in detail. It reduces information asymmetry in the marketplace, therefore creating value for energy efficiency in real estate transactions. It supports energy efficiency investment, facilitates energy efficiency services, implementation of other programs, creates lots of products, services, investments for the local economy. So doing benchmarking at the city level kind of creates a really bottom-up, transparent, and credible mechanism that can lead to market transformation. And this is something, because it's driven by the city, it's local data, contextual. There's much more credibility in the whole system. There's much more transparency, and therefore the cities really are in charge of driving the agenda depending on the vision that they may set for themselves. Having said that, doing it is not very easy, and different cities in different countries have different level of autonomy to do such things. So you need to have some legal provision to do this. Who owns this initiative at the city level? Is it within the city's mandate to implement this? Then there are some challenges, and how's the program designed? Who administers? Who enforces? Whole issue or technical issues around data, creating a benchmarking tool that kind of allows you to do all of this, and then integration with other agencies. So the property records may be with the revenue department, the energy consumption may be with the utility. So different agencies are sitting on different data sources, and you need them to talk to each other and share data while maintaining the privacy and other issues, and of course capacity building to do all of this. And there are lots of challenges to have a successful city level program. So I think the most important is stakeholder mobilization, and if you're able to do that well, get the city on board, get the local real estate association buy-in, get different departments, revenue department, utility department on board, then that is a major win. Of course, we have to do a lot of interagency coordination, look at energy consumption beyond electricity. So if they have captive power, diesel generator sets, gas, how do you build all of that in? And many times the data for all these different fuel types are not well recorded because they're not coming necessarily from the formal sector. Then there are on-ground challenges like multi-tenant buildings, multi-use buildings, metering infrastructure may be messed up, whole issues around data and technical capacity of the city to actually manage a program like that, right? And funding and sustainability. So you have one good city leader who wants to do this, but can the program sustain beyond one person's interest? So how do you institutionalize all of this at the city for long-term sustainability? So I would stop quickly and say that city level benchmarking is a promising low-cost, target-oriented, sustainable approach for Indian cities and elsewhere for reducing and monitoring emissions from building operations, right? Because it allows you to set your own targets, monitor them, plan accordingly, and track, and say over time, that you're really improving or not improving, and by how much, and then what needs to be done, simultaneously leading to or supporting a market transformation initiative. Right? These are some of our work that we have been involved in with different agencies in India on the benchmarking program, and I think at least on 2 of them, Lawrence Berkeley was a partner organization that we worked with. So, and all of this is available on our website, so you can go and download the paper from there. And I'll stop here. So thank you.
Thank you, Dr. Saket, for setting the stage and sharing with us the benefits, and also in terms of the different methods and modalities for benchmarking. Also, it's great to see all these resources, and we definitely would like to also share these with participants post the webinar. Yeah, we would just go to questions now. So if any of the participants want to speak and ask questions to Dr. Saket, please kindly raise your hands, or we don't see any questions in the chat box, but if you raise your hands, we can unmute you and you can ask questions. While that's happening, maybe one question from our side, Dr. Saket. So here on the screen, we see yeah, something that you alluded to again, that the $1 million question is on data.
Right.
And you refer to some research that's done on energy disclosure laws. What do you think, from a city perspective, for a city that's mulling such a law, what major factors should a city consider, and what would be the right modular approach for them to go for? Thank you.
Yeah. So if you want the city, like the urban local body, to lead this initiative, I think first thing that they need to do is create an interagency kind of an agreement which allows them to share data, say, of the property records, of the building use, tax information, utility, energy consumption, right? Again, there are two models. It can be top down, that the data is shared through under a legal framework, or it can be a voluntary bottom-up approach where the buildings themselves have to kind of disclose all of these things to a central portal. Right. So again, depending on the city, either of the two ways of data sharing can be done. It can be a hybrid, that some data is auto-populated. So say the floor area comes from property records, energy consumption comes from the utility, and the use characteristics come from the property owner or manager, right? And everything feeds into a central database. Then you'll have to kind of create policies around the privacy of the data and who can see the data and who can manage the data, and some data quality control things, right? So it's an ecosystem that you'll have to set up. But the good thing is that once you do set up that ecosystem, it would make it much easier in the long run compared to the other approach where you actually survey the buildings one by one, and once you finish the survey, then that survey is never updated, and you are unable to track things, right? So does that answer your question?
Yeah, thank you. I think we have an audience question.
Yeah.
Anand. Yeah.
Yes. There's a question from Karma user. So Mr. Karma, we will unmute you. You can ask Saket your question. You have self-muted. Maybe you need to unmute to be able to speak. Karma user.
Hello, sir. Can you hear me?
Yes.
So my concern about implementing this energy efficient measures in buildings is regarding the cost factor that surrounds the manufacturers and the implementers. So how do we actually control that? How do we, or is there anything we can do to control the cost that is put up to us while implementing these measures?
Cost to whom? To the building owners or to the city, or
Both, or all?
okay, so there are different kind of cost involved in such a program. The one is the cost of compliance, right? That is it an extra burden on the building owners, the facility managers, to just comply? So you need to create a program which really minimizes the cost of compliance, right? And again, it can be a kind of a graduated approach that the compliance is very simple, but you have kind of levels of benchmarking tools which goes beyond compliance and helps you to really improve your building performance, right? But purely from the compliance base, the cost can be really kept at a very low level from a owner, facilitator, manager's perspective. I think you said manufacturers, so having a program at city levels would actually spur a lot of demand for energy efficient appliances, systems, technology, services. And it will actually bring down the cost of energy service and energy products in the market, and energy efficient materials for that matter, envelope materials, right? The cost for the city, yeah, we'll have to think on where does that money come from, where does the city get the money to fund a program like this, right? And of course there are models that we can talk about, and then there will be some cost that would be there to incentivize people to kind of join this program, and but that can be, say, dovetailed with a demand side management program of the utility. So you have to see all the kinds of resources available on the table that can be leveraged by one agency or the other, but with the aim that overall the stock in the city improves, right? And how the benefits are shared in some equitable manner among all the stakeholders.
Thank you.
Thank you.
Thank you,
Yeah.
Saket. We have a
Go on.
question from Jyotirmay Mathur. So we have unmuted you, Jyotirmay. You can please ask your question.
Hi, Saket. Good morning. Good morning.
Hi, Jyotirmay. Good morning. Long time.
Yeah. So good to see your presentation.
Sorry to jump in, but maybe it would also be useful if participants just introduce themselves briefly, your organization background when you ask the question, so that speakers also have that context. Thank you. Sorry.
So my simple introduction is that I am a friend of Saket, and I'm a professor at NIT Jaipur. I teach energy, and I've been part of various initiatives at national level, including ECBC. So, Saket, I have a question. There are few, and you are definitely expert of this benchmarking affair. So, there are few approaches, and one is the black box approach, and the other one is the white box approach, and the third one is the gray box approach. So,
Yes.
which one do you recommend is good for a building level, and which one is good for a city level? Considering that there are always data collection challenges at both the levels, whether it is building level or city level, data collection challenges, especially in India, are there. So,
yes.
Which one is more reliable method as per your recommendation?
Yeah, that's a very, very interesting question and a very important question. So I would start, Jyotirmay, with saying that whether it's a black box, white box, or gray box also depends on who is looking at it. So something which is a white box for a very technical person like you may be black box for a building manager or a building operator, right? So that is one perspective. I think all the approaches should be white box for some stakeholders, depending on their level of interest in the system. It may be gray and black for other stakeholders, but it should be white box for the relevant stakeholders for sure. So that's a simplest answer, right? Somebody should be able to say why is their building being labeled, or the benchmark score that they get is XYZ. So that should be attributable to some characteristics or some data that they are entering into the system. Right?
So, Saket, the data collection challenges are enormous in white box, right?
Yeah.
And so if we accept that data collection is there a problem, and the data quality is also not good, do you still recommend practically a white box method or something in gray box or black box, for example, Bayesian model or other things which are used worldwide in some of the places.
Yeah. So ultimately, it would be a gray box thing, right? But it's the shades of the gray. So the aim is to keep it as white as possible and support it by, say, hybrid data, synthetic data, simulation data for things for which you don't have sufficient on-ground data. But that too can be done more transparently. And the idea of a bottom-up benchmarking effort is that over time you are creating a much more credible bottom-up database, rather than a top-down survey from a national level where you cannot revisit. So when you're doing something like this at a city level, it's and the buildings are part of the system, so they are continuously feeding data into the system. And you can do this in a phased manner that every year or every few years you expand the scope of data that goes into the system. Right? But you also need to understand how that data is collected and how credible that data is. Yeah.
Any comparison of same set of data being applied on a white box or gray box or black box, and how different are the benchmarks likely to be from one approach to another approach?
No, so all the work that we have done so far is kind of, or I see them as more white box thing. We have attempted some models using a hybrid approach, but again, then you kind of go into a graduated approach. So my take on it is that the first model, the one which is to do simple benchmarking and simple certification, has to be on a kind of a white box on real data collected from ground. And the minute you try to become much more actionable, you kind of start augmenting it with other kind of data. But for the first level, it has to be actual data from the ground for the buildings.
Okay, thanks again.
Thank you.
And we should continue this discussion, Jyotirmay. It's a very important topic.
Definitely.
Thank you. We have a couple of other questions. Maybe we'll just take them up later. We now move on to the next presentation. And I'd invite Caroline now to share experiences from the region with the lab's work. Over to you, Caroline.
Thank you. Okay. All right. So can folks see my screen okay?
Yeah, we're able to see.
Okay, thanks. Wonderful. Thanks so much, everyone. So today I'm going to be speaking about energy performance benchmarking in Asia and sharing some of my own experiences in the region. Okay, so bear with me here. I'm just going to hide my other screens here. So in terms of today's agenda, I'll briefly provide some background and context on energy benchmarking, although I think Saket and I would agree on pretty much everything he presented, but you may want to see that reiterated here in some of these Berkeley Lab perspectives. And then I'll talk about 4 case studies, one from China related to their building energy saving tool and an emerging Best Plus tool. I'll talk about my own work in Indonesia, developing a hotel energy performance benchmarking tool prototype under a USAID project. We'll go back to China to talk about application of benchmarking in a Chongqing low carbon district in Shanghai. And then an emerging building efficiency targeting tool for energy retrofit, sort of a next generation benchmarking tool, which is free and open source and can be applied globally. So just, a bit of context. I like to keep this data fresh so that we all remember how critical the building sector is. It's the largest source of primary energy consumption globally and ranks second after the industrial sector as a global source of indirect and direct CO2 emissions. But according to the World Economic Forum, Nearly 1/2 of all energy consumed by buildings could be avoided with new energy efficient systems and equipment. And of course, benchmarking, which is comparing a building's energy performance to peers or other standards, helps us determine which buildings are candidates for improvements in energy efficiency. It can help us achieve these potential savings in building energy usage. So what has experience shown us in Asia? So I've worked in energy efficiency market transformation in Asia since about 2003. I've worked with approximately 10,000 building property managers across 15 cities in Asia, including India, Greater China, Indonesia, Philippines, Vietnam. And what my experience has shown is that buildings that benchmark, that find ways to measure and compare their energy performance to peers and to track performance improvement over time, and that are able to identify and implement simple, no-cost, low-cost operations and management measures or operations and maintenance measures, can reduce their energy use 10 to 20% annually easily. So I think there was a question earlier in the workshop about cost and potentially cost to building owners to improve energy performance. And what I want to say here is research done in the United States under the U.S. Environmental Protection Agency's Energy Star program, where we assess the technology profile of our top performing buildings. Those in the United States that are Energy Star certified and they're 35% more efficient than typical buildings don't actually have a technology profile that's different from the worst performing buildings. It was a really surprising finding. We saw that the technology in the best performing buildings and the worst performing buildings was quite similar. But the difference was that the buildings that were top performers had very active energy management programs, and they had a commitment to operations and maintenance of their equipment. They knew how to operate their equipment to achieve high levels of energy performance. And so in subsequent programs in North America and throughout Asia, funded by USAID, funded by Department of State, funded by EPA, we've really honed in on no-cost, low-cost O&M as a way to drive building energy performance improvement along with benchmarking. So anyhow, you'll see some statistics here at the bottom of the slide. The USAID, US-China Sustainable Buildings Partnership Program was one program I was involved in where we trained almost 5,000 engineers and almost 9,000 buildings over a 4-year period and saved energy equivalent to 3.4 billion kilowatt hours, 465 million in energy costs, and reduced GHG emissions equivalent to planting 72.5 million new trees. When we had a lot of case studies, so I'm gonna move to the next slide here. So as I mentioned, the US-China Sustainable Buildings Partnership was implemented by USAID in China from about 2008 to 2012. Under that program, we developed for China the first building energy performance benchmarking tool for China, and it was called BEST, Building Energy Savings Tool. It was based on the US Energy Star Portfolio Manager benchmarking tool, which I'm sure many of you are familiar with. I know Socket is familiar with this model. It's been used by about half of the US commercial building stock since its inception in the early 2000s. It's helped organizations save billions in energy costs since 2015 under a larger energy efficiency market transformation program, the Energy Star program. As of the end of 2016, there were 23 local governments in 2 states that used the Portfolio Manager benchmarking system as the foundation of their energy benchmarking and transparency policies. So Socket also mentioned disclosure programs emerging in India there are a number of these programs, I guess. Currently, there are almost 30 of them in the United States, and many of them rely on Energy Star Portfolio Manager as their go-to performance benchmarking tool. Again, to support regular benchmarking and transparency, disclosure of building performance, energy performance in the marketplace, which helps to incentivize actions on energy efficiency, creates jobs in energy efficiency, of course, drives down energy consumption and greenhouse gas emissions. Energy Star Portfolio Manager in many ways is a certification tool. It's intended to provide recognition to buildings that are in the top quartile of the US market, buildings that benchmark with Energy Star Portfolio Manager and earn a score of 75 or above are eligible for the Energy Star plaque, which certifies to the market that they're 35%, that they use 35% less energy than typical buildings in the nation. So to date, there are more than 7,500 buildings that have earned the Energy Star plaque. Sorry, in 1 year alone, the most recent data we have is 2016. There are 7,500 buildings that earned the Energy Star that year, and total certifications in the US are close to 30,000. So again, China took the example of Energy Star and they created BEST. They used the exact same methodology, in fact, for benchmarking building energy performance, beginning with large-scale data collection, analysis of that data to identify the key factors that contribute to energy consumption in Chinese buildings, creating algorithms to normalize for those factors and fairly compare one building's energy efficiency level to similar buildings in the market. And again, everything was drawn from the Energy Star technical methodology information, which is available online in the US. So China's inaugural BEST tool was developed for 4 space types: offices, hotels, hospitals, and shopping malls. You can see here a quick snapshot of one of the interface pages where, in this case, the tool is allowing a user to see their benchmark score, which is a 1 to 100 rating, where 50 would be considered average and a score of 75 would indicate performance better than 75% of similar buildings in the market. And also on this page, a user could plot progress in reducing energy consumption and CO2 emissions over time. In this component or portion of the BEST tool, a user is able to see energy intensity levels for different benchmark scores and plan energy efficiency projects in their building. Under the USAID program, we worked with Johnson Controls in their Beijing office to train their sales force on how to leverage BEST to benchmark customer facilities and advance the sale of services and technologies in China. And you can just see a quote there from the management and sales force at JCI Beijing. Our guidance to the Johnson Controls team in Beijing around how to use BEST to sell energy efficiency services and equipment focused on helping them make the business case for energy efficiency investment in Chinese buildings, identifying, of course, buildings where technology retrofits could be most cost effective due to magnitude of energy savings, measuring energy and cost savings of building retrofits and operational improvement projects post-implementation, identifying buildings that could readily achieve 3-star or LEED certification, and of course, improving customer satisfaction. Since the BEST tool was launched online, China has also developed an app. So this is just, you can see this is sort of in a smartphone size where they contain all of the same data inputs and features as in the web-based tool. So I'll show a few screenshots here. You can see here where monthly energy consumption data is input into the app. and of course, detailed information on the building, the score, and some information on energy use intensity as pertains to that score. Currently, under a US Department of Energy program, we're working with China on what we call Best Plus. So we're working on a tool that's modeled after the Berkeley Lab and Johnson Controls Better tool, which I'll talk about at the end of today's program. And this goes a little bit beyond the Energy Star benchmarking methodology to not only provide a comparison of one building's energy performance against peers, but also to provide guidance on the potential energy cost and greenhouse gas emission reduction for a building or an entire portfolio, and also the energy efficiency actions that should be implemented in the building to capture the energy cost and greenhouse gas emissions reduction potential. So I'm going to just show a few screenshots and then talk more about this when I speak on Better. Essentially, what China has done is taken the source code, which is open, and then use that as their analytical engine and then created this nice interface. But essentially what Better will do is help to create a prediction of the energy consumption, the monthly energy consumption in a building, assuming some of the energy efficiency recommendations recommended by the tool are implemented. It'll also provide inverse models or change point models for the fossil and the electric consumption in a building. It'll isolate and benchmark 5 coefficients of performance within these inverse models: base load, heating and sensitive consumption, heating and cooling change point, and tell you whether a building's base load is good, typical, poor, whether a building's heating change point is good, typical, poor, and so on. And from these inverse models and benchmarks to suggest specific energy efficiency improvements. Most of these are no cost, low cost. They can be implemented immediately by a building management team, so that those savings can be captured. Some will be CapEx, OpEx, and require audits and expenditure. So we've designed the tool to be implemented at many levels and on many budgets. I'll speak briefly about Indonesia. So as I mentioned, right around 2013 to 2015, I worked on a USAID program in Indonesia called the Energy Efficiency for Clean Development Program. And there again, we took the model of Energy Star and we created a prototype for the Indonesia hotel market, whereby our benchmarking prototype would provide a score 1 to 100, where 75 is performance better than 75% of similar hotels in the market, and would normalize for the key drivers of energy consumption in Indonesian hotels, such as occupancy, weather, size, etc. All those factors outside the owner or manager's control that we need to normalize for in order to do an equitable comparison of energy efficiency. We converted site to source energy, so we were benchmarking based on source energy. We acquired data through acquisition of large national hotel data sets. We worked with a hotel consultancy called Horwath, and we got building energy consumption data through their annual survey, which was a great undertaking and an example of a public-private partnership working with Horwath. And of course, Indonesia was able to take this prototype and apply it to support identifications of buildings that might be eligible for their green ship rating system. And of course, other applications. We started in the hotel sector in Indonesia because, you know, there's so many hotels in Indonesia and they consume a lot of energy, a lot of 5-star hotels. And it was a sector in which data was readily available and there was a lot of energy and cost saving potential. So that ended up being a very successful pilot program. I'll just talk briefly about China, Shanghai, the Changning district. So in the while we were developing China's prototype building energy saving tool and the app, and now we're working on Best Plus, the World Bank was funding a low carbon city initiative in Chongqing district of Shanghai. So one of 16 districts in Shanghai, mostly commercial buildings. And this district was seeking to be a leader globally in low carbon city and low carbon district. So they acquired a grant from the International Bank for Reconstruction and Development and the Global Environment Facility, which allowed them to implement a program to identify and retrofit buildings within the district to be more energy efficient. And so part of what the district needed to do was to determine which buildings were essentially good candidates for retrofits. Where were there energy hogs? Where were those high energy consuming buildings that were likely to drive energy and cost savings and greenhouse gas emission reductions? So the district looked at a number of different methods for essentially benchmarking in order to determine which subset of buildings they would retrofit. One was to use national building codes as targets. So if buildings were not complying with the national building code, they would be targets for retrofits. Another approach was performance-based targets, where they looked at 4 methods, just simple kWh per square meter or energy use intensity benchmarks, which we're all familiar with. They're really easy to implement, but of course they don't factor for those variables such as differences in occupancy or operating hours that affect a building's overall energy consumption, but don't necessarily mean a building is more or less energy efficient than another building. They also experimented with the energy use intensity benchmarking by building categories. So they grouped buildings into subcategories, maybe by type or location, then experimented with using EUI within those subsets. Ultimately, they determined that they were going to use a normalized benchmarking method, which is the method that Socket described and Energy Star portfolio uses. So essentially identifying the key drivers of energy use in buildings and then normalizing for those factors. And they determined that that was the most equitable approach to benchmarking and the one that would that most building owners would deem fair if their building was selected for efficiency improvements. So we did a little bit of support and guidance to Chongqing District on how to set energy use benchmarks using that normalized target setting approach. And you can see a little bit of our analysis here. What I'll say was the pilot ended up being quite successful. It was a 60-month period pilot, so five years. And they ended up retrofitting 45 existing commercial buildings, about 2.87 million square meters. They saved 31,000 tons of standard coal and reduced their emissions by about 63,285 tons of carbon dioxide emissions. And they were quite good at the outreach, their communications of the savings and the impact. And it's become a very well-documented case study, and WRI BEA has a playbook that includes this in-depth case study on their benchmarking methods and success. So that brings me to the last piece here, which is BETTER, the Building Efficiency Targeting Tool for Energy Retrofits. This is a new and emerging technology for benchmarking and targeting of retrofits. It's sort of a next generation benchmarking tool. It's developed by Lawrence Berkeley National Lab. It's web-based. It's free, and its source code is available on GitHub. So anyone can download the source code. It's in Python. They can, adapt it, redistribute it, what have you, in accordance with our open source software license. So you'll want to check that out. We designed it to run on the most basic of building energy data. Socket got to that issue around data being, the #1 barrier to benchmarking. So we've designed a tool that runs on monthly energy usage, utility bills, essentially building size, location, and type. And we automatically regress monthly electricity and fossil fuel usage with the tool against ambient temperatures, and then we benchmark those 5 regression model coefficients that I mentioned for the Best Plus tool. We quantify energy cost, GHG potential reduction at the building and portfolio level, and we recommend energy efficiency interventions, again, at the building and portfolio level. Socket mentioned this, scalable application. We're not interested in a few high profile green certified buildings, but we want the entire market to move forward in terms of energy performance. And this type of tool, Better, is designed to do that, to benchmark hundreds of buildings in a single analytical run in order to derive the energy and the cost savings potential and understand where your high saving opportunities exist. We have an API, so for software engineering teams that want to use our application programming interface to exchange data and metrics with us, we can certainly do that, and our algorithms, our metrics can be incorporated into your software tools. Investor application, very, very important. We think there's a real opportunity to use tools such as Better to quantify energy efficiency in financial terms, the net operating income increase and the asset value increase through energy efficiency in buildings and portfolios, which can be quite substantial. So in conclusion, here's some of the benefits of benchmarking. I won't go into these because I know I'm over time. And Socket, I think, hit on many of these, but those are a few case studies from the region, and I'm happy to take questions.
Thank you, Caroline. So we request audience, if you have any questions for Caroline, please raise your hands and can get to it. Since Caroline is also in the US and it's quite late there, so she'll be leaving us in 5 minutes or so. So this is the last opportunity to get any questions or queries answered. Yeah, maybe one question from our side, Caroline.
Oh, sure.
Yeah, from all the experiences that you presented from US, China, Indonesia as well. So could you share some, some best practices or approaches that are used to engage? You referred to various actors in the community or the private sector. So how can, in a city-led initiative on benchmarking, such actors be better engaged?
Yeah, thanks. That's a great question. So one of the ways that I've found most effective to engage the private sector is to speak to the bottom line and speak to the financial benefits. You almost don't need to mention environmental benefits or carbon dioxide emission reduction in certain private sector audiences that are very critically focused on again, the bottom line. So we were able to engage Blackstone, the world's largest alternative asset management company, with a real estate investment portfolio valued at over $500 million. A lot of their portfolio is in India. We don't talk about CO2 emissions when we talk to Blackstone. We talk about net operating income increase and asset value increase. And so for those of you involved in real estate, you may be aware of that critical equation. The asset value is equivalent to the NOI divided by the CapEx, or the cap rate. So for every dollar that you can increase the net operating income through energy efficiency gains and energy cost savings, you can multiply by a factor of 15 to get the asset value increase. So for real estate owners and investors, that's a critical equation. And Blackstone has been a huge investor in energy efficiency, taking a no-cost, low-cost approach across their real estate assets. as an asset manager, there are a number of pension funds in the United States that invest and hold Blackstone assets in their portfolio. So you also benefit, shareholders, the average investor in a pension fund at a university, the average university employee or lab employee. They're going to see, because of these asset value increases, they're going to see higher shareholders, returns. So that's one of the ways we've engaged the private sector, just really focusing on the financial business case.
Thanks, Caroline. Maybe Dr. Saket has something to add.
Yeah, no, I was, Caroline, really very impressed with the fact that you made the better tool open source on GitHub, publicly available, because now going ahead, if any cities, any community wants to do that, they don't have to reinvent the wheel from scratch. They have a framework, they punch in the data, recalibrate the model, and they can just build on the expertise that your team has put together. So it really brings down the cost of a tool substantially, low for faster adoption. Otherwise, every time a community has to have a tool, they have to kind of invest into, some technical expert, some interface, and miss on critical learnings that others have had. So when I was discussing with, say, the Kochi team, they were making the same errors I made about a decade ago, right? And every time we start from scratch, but doing what your team has done is put it in the public domain. So it kind of transfers that knowledge to any new entrant in the domain, and which is really commendable. So thank you for that.
Oh, our pleasure. Thanks, Saket. That's great. Yes, you make a very important point. And as mentioned, we hope we can work with you going forward when there are cases where perhaps a city in India wants to take that source code. I think the only requirement is that any enhancements to the source code are shared with the Berkeley Lab team, so that we also benefit, and we learn together.
Sure. And Berkeley Labs has been a very important partner in the Indian benchmarking effort so far. So of course, there's a lot of synergy there.
Yes.
Thanks, Caroline, again for sharing the tools. I think we will also, of course, our participants also will be interested in knowing more about these, definitely. Yeah, absolutely. I think we also have a question from the audience. Over to you, Anand.
I have a question from Jasreel from UNDP. We'll unmute you, Jasreel. You can ask your question. You are self-muted. You may need to unmute. Jasreel?
Yes. Miss Caroline, can you cite some of the effects that the BEST Plus have predicted in terms of implementing the efficiency measures to a building?
Oh, sure. Yeah, so that's a great question. So BEST Plus recommends up to 14 energy efficiency improvements, either improvements to the base load energy efficiency of a building through, for example, recommending a lighting upgrade, or improvements in lighting performance, or improvements to, for example, in the case of base load, perhaps improvements to the plug load and process load efficiency in the building, which don't relate to heating and cooling consumption. So within that category of lighting, BEST Plus would hone in, would give you a broad recommendation to improve lighting performance in the building. And then there might be, 5 or 6 options which an owner can determine which of those they'd want to proceed with. We always include no-cost options, such as, de-lamping, or low-cost options, such as installing sensors. Other no-cost options might be in the hotel sector, kind of loading your hotel occupancy in certain ways to minimize lighting levels. So base load is one example in the Best Plus tool. Of course, also they would have recommendations for improving the cooling and heating change points, or the cooling and heating balance points in the building, which is the temperature at which the heating or cooling system in a building would engage. You might get a recommendation to increase the cooling change point for the building, and then possible no-cost, low-cost O&M measures might be to improve the temperature set points for your equipment. You might also get a recommendation to sort of optimize the equipment schedules using your building automation system. So those are some examples, and I'd be happy to direct you to a full training on the energy efficiency measures in Best Plus, which are actually identical to those in Better. So there's 14 energy efficiency measures.
Thank you. Thank you
Thank
for
you
that.
for answering my question.
Yeah, in the interest of time, I think we'll move on, and for any other questions to Carolyn, please write to us during or post the webinar, and we'll make sure that they get to her and she can respond. Thank you.
Thank you.
We now have a presentation on a benchmarking effort done in Kochi, and we now invite Dylan from WRI India to speak, please, and share insights on the work. Thank you.
Yeah, thanks, Nigel. So, hi everyone. Good morning to all. My name is Dylan Subramanian, and I'm working as a Senior Project Associate, Energy Program, WRI India. So, can we go to next slide, please, Nigel? Okay. So, I will be talking about the energy benchmarking work that we have done in Kochi for office buildings under the Building Efficiency Accelerator program. Okay, so as a disclaimer, I would like to say that this is an ongoing work, and whatever observations and findings that we are presenting here are just interim observations and findings only. So I'll be talking about that later. So to give you an introduction, to give you a brief background, I will start with how our engagement with Kochi started. So our engagement with Kochi started in 2018 for developing a zero carbon building roadmap for the city. So we have identified some near-term, long-term, and mid-term actions for the city to make this transition possible, to the zero carbon building transition possible. So energy benchmarking for existing buildings in Kochi was one of those near-term action items. So this was one of the reasons why we have selected Kochi to do this particular work. So that's it. That's it about the background why we have selected Kochi. And I understand that we have people from all over the world joining the presentation. So for those people who are not aware of the geographical location of Kochi, please see where Kochi is in. We have given a map over there. So Kochi is a major city in Kerala. So this is where Kochi is located, in the southern end of the country. Okay, so I'll talk about the objective and the scope of the study to start with. So the objective was to understand, evaluate, and benchmark the energy performance to the office buildings only. Sorry. Hello.
Yeah, we can hear you.
Okay, I just lost connection with you. Okay. So yeah, I was talking about the objective of the work. So the objective of the work is to understand, evaluate, and benchmark the energy performance of office spaces in Kochi, and to inform the building owners and tenants about their performance based on the benchmarking. This was the objective behind the work. The scope of the buildings, we have only considered these buildings for the work that we have done in Kochi. So we have only considered consumers with total connected load above 75 kilowatt, and we have only considered those buildings which were reported as office by the utility of the state government, which is Kerala State Electricity Board. So these were the two criteria that we have considered for selecting the buildings for this particular work. Can we go to the next slide, please, Nikhil? Okay. This is the methodology that we have considered for selecting the sample size of buildings. So based on the two criteria that I have already mentioned, we had 91 buildings identified, and out of that, 62 buildings were selected for the benchmarking. And all these 62 buildings were located through across the city, and that was done quite intentionally. We need to make sure the geographical representation we need to justify the geographical representation of these buildings as well. So for that reason, we have selected buildings from 11 subdivisions of the utility, and we have selected 62 buildings from these 11 subdivisions. So based on out of these 62 buildings, there were different ownerships as well. So as Sakesh has already mentioned, while we do a building benchmark work, the major challenge would be these buildings will be having different ownership, different category, all those things will be there, and we had made sure that we are taking care of that factors as well. Okay, can we go to next slide? So this is the basic methodology that we have followed for doing our work. So there were some 6 basic steps like we have for which we have followed to perform this work. So I'll talk about the 6 steps that you have. The step 1 was identifying the buildings. I have already mentioned about what were the criteria that we have followed for identifying the buildings and all. And the second step was data collection. So we have hired a survey agent to perform the survey. And the step 3 is data analysis. Actually, this step was the major step, and this step was the we have consumed a lot of time doing this particular step, because it was very important for us to analyze the data that we have gained and to get important information and and to derive important findings and information from the data that we have had. So I would like to acknowledge Mr. Dr. Saket's contribution in that area. We have been continuously in engagement with Dr. Saket for his guidance over this to complete this data analysis. Initially, we were using some other software, and we have transformed to our software to do this analysis completely. So all these things were happened only mainly because of Dr. Saket. So and after that, the 4th step is establishing the building performance index. So I'll talk about what building performance index later. And the step 5 is ranking the buildings based on their BPIs. And step 6 is informing the building owners and tenants about the building performance. This was an important step as well, because it was not just doing the benchmarking work and keeping it aside. We were also trying to make the building owners and tenants informed about how their buildings are performing and all those things. And this was an important step. So I'll talk about the building performance index now. So building performance BPI stands for building performance index, and it is defined as the ratio of actual energy consumed to the estimated consumption of a similar benchmark building using the regression equation. So after doing the data analysis, we will be having some sort of a regression equation which will give us the annual energy consumption of a particular building. So that will be common for that particular data set, and that will be that's a common thing, and we will be using the actual consumption and the consumption that we got from the regression equation to derive this BPI. Okay, so that is BPI. It's a very important parameter in terms of building benchmarking analysis. So that's about we had calculated all the BPI for all the buildings based on their actual and predicted electricity consumption for doing this analysis. So next slide, please, Nikhil. Okay. Okay. Yes. So I have already mentioned this, we have we have used our studio for the data analysis, statistical analysis and all. So again, as I told before, this data analysis itself was a very time-consuming process, and we had to start with data cleaning, mainly because whatever buildings that we have surveyed will be having buildings with different characteristics, and it is very important to homogenize the data set that we have, to make sure that all buildings are having some sort of similarities and working characteristics. So that's a very important step. And the next step was to do the bivariate analysis. So bivariate analysis again is very important to see how buildings are performing in terms of different parameters. And we have done a breakpoint analysis as well. Then multiple regression, then regression diagnostics. We have performed different diagnostics to see whether the statistical model is good enough, whether we can go with that or not. So all these things were done quite very closely, and the other important point that need to be noted is that there were some independent variables based on which we have made the regression analysis. So these were the three parameters. The first one was built-up area, and the second one was employee density, and the third one was air-conditioned area. So the independent variables essentially means that these three parameters played very significant role to in determining the energy consumption of that particular building. Like whatever buildings that we have considered for this particular exercise, these three parameters played a very influential role in predicting the energy consumption. And this was concluded based on the significance of their p-value as well. Okay, the dependent variable in our case was annual electricity consumption. So what we have collected annual electricity consumption from the Kerala State Electricity Building, Kerala State Electricity Board of the state, which is the utility of the state. Next slide, please, Nikhil. So these are the interim findings. As I told before, we are still working on this. So this is just whatever we are presenting is just an interim things. So you can see the first graph is showing the building performance index of buildings along with the building IDs. So in the x-axis, what you can see is building ID. So we have 50 buildings. So we have 50 building IDs. And we have building performance index from 0 to almost 2.2, 2.3, something like that. So what this essentially means is that higher the building performance index, it means that the buildings need to be it can perform better. It's consuming more energy than it is supposed to be. That's what higher building performance index is indicating. So we can clearly see that the below graph is showing the rank that these buildings have secured. So the relationship is quite proportional. Like whenever the building performance index is on the higher side, the building's rank would not be very good. So the highest BPI building will be having the 50th rank in terms of the energy efficiency. So this is what these graphs are presenting. Next slide, please, Nikhil. So these are the interim observations that we have had after completing after doing the whatever work that we have completed so far. So 20 buildings were found to have lower electricity consumption than the predicted consumption. So this essentially means that 20 buildings are energy efficient compared to on the basis of the analysis that we have had. So highest ranked buildings was found to be consuming only 30% of the its predicted electricity consumption, and the lowest ranked building is consuming more than 2 times of its predicted consumption value. So this indicates the two extremes of building performances in the city. So these are the interim observations that we have had so far. This is a glimpse of work that we have done. I have made it very short to make sure that we are sticking to the time. So our future steps would be we are planning to write a working paper on this. Like we will be sharing the detailed findings from this study to a working paper by the end of this year. Okay, so in the future, we would like to see this coming up in a much better, much larger scale, with more building typology, with more buildings within the data set. So we are expecting that to happen in the future. So this is all about the work. Like if you guys have any sort of questions, happy to take it.
Thank you, Dillon. It's great to see that Kochi could do this exercise for a sizable sample of offices, and also interesting to know more on the statistical analysis and the interdependencies that emerge. Participants, please note we'll take questions for Dylan after the next case study from India, so that questions from both efforts in both Indian cities can be addressed together. Also, looking at the time, I think we will, extremely sorry for this, but we will extend possibly by 10 minutes. Yeah. So now I'll be presenting on a case from Nagpur. So this is on benchmarking done for 2 building types in Nagpur with the support of the Building Efficiency Accelerator. My organization, ICLEI South Asia, was involved in implementing this technical activity with the city agencies. Next slide, please. Yeah, so Nagpur is a city in central India. The city's agencies, the municipal government and its smart city agency, they were interested to advance building energy efficiency locally. And they joined the BA initiative in 2018. The BA then supported the city to undertake activities to help meet its goals. So in terms of objectives specifically for existing buildings, the intent was to understand baseline energy performance and also opportunities for improvement of efficiency. And the way to do it, which was identified, was to test a process for benchmarking of performance and then also subsequent prioritization of the buildings for energy efficiency action. A sample set of 2 buildings was targeted or is targeted with the intent to scale this up, scale this activity going forward. Next slide, please. Coming to the process and activities for benchmarking. So in terms of the selection of the building types, this also has relevance with the city's economy and structure. So based on the Nagpur being a administrative center and not really a technology hub as such, and depending on the stakeholder interest, 2 typologies were identified with potential. So these were hotels and public buildings. In terms of the benchmarking process, so through stakeholder engagement, buildings were selected for benchmarking survey. And again, these were 10 private hotels and 10 city office buildings. Then we went through a process of data collection, benchmarking data was gathered, analyzed, and then as a last step in the benchmarking piece, buildings were shortlisted from this sample to undergo detailed audits. This entire process took about a year, including the audits. The detailed energy audits were conducted eventually in 2 public offices and 2 hotels. And the audits, of course, the detailed audits identified energy efficiency interventions, saving potential, also supplemented with cost-benefit analysis. So all this could, the intent was to demonstrate this process and the benefits and potential to the city government, to decision makers, as well as to other stakeholders involved in this exercise. Next slide, please. Yeah, some further information on the benchmarking. So the public offices were typically smaller offices, and the hotels were primarily small to mid-size hotels, and most of them were 3-star rated or below. For benchmarking, data was collected, typical information on electricity consumption, building information for benchmarking, such as area, and also supporting contextual information, such as the age of the buildings, connected load, use of other energy types. since this was a city's first attempt on benchmarking, and also that the focus was more on peer benchmarking analysis for prioritization, and given the information available, so a simplistic EPI was the metric chosen at the whole building level to undertake the benchmarking. I won't get into the statistical details of the EPI and the charts on the right. A couple of larger findings are there in the subsequent slides. Next slide, please. So I think everyone has alluded to the data collection, data availability challenges. And I think what we also observed was like logging of energy data was found to be missing in both building types at times. Also, basic building information such as floor area at times was not easily available, even with the city authority for some of its own buildings. Given some of these buildings are quite old. So interactions with stakeholders are essential to address such gaps and also to give contextual information, such as operational patterns and so on, to support the numbers and hard data. In terms of the EPI related observations, so the hotel's EPI increases with the hotel size. And also the amenities. A few outliers were noticed. For example, one hotel had low EPI but high connected load. So the low EPI was not really a result of its efficiency, but it was more that the hotel had a large area reserved for events, which were intermittent, and that's why it was not really the energy. It was not something that was driving energy consumption, and that's why the hotel had low EPI. So then there are further aspects such as the number of rooms. Possibly that correlation can be explored for EPI. Since this was a starting, this was the first time that the city was doing it. So there are, of course, going forward, the city is going to look at making this more robust and looking at other operations approaches as well. In terms of offices also, we saw, and it's been talked about by other speakers as well, that operational details in terms of visitors, utilization of space, and so on, that also impacts the EPI. But definitely, even at a high level, gathering this information did help to create an evidence base to identify opportunities, even in offices of smaller size that possibly could be overlooked usually in such exercises. Overall, I think, the benchmarking and the pilot audits did find notable potential for energy saving, especially from low-cost interventions. So energy savings from such low-cost measures in the hotels and buildings range from 10 to 33%, which is quite significant. And if you look at the investment also, it's quite reasonable for a city government or private owner occupier to take on. A key point, I think, is again, in this case, the city started out small and at a manageable scale. So I think benchmarking efforts should be initiated with clearly defined goals and also considering local level practicalities. And going forward, you can always add in better data analysis, expand sample size, also further formalize the process going forward. And the gradual efforts also help in engaging and mobilizing stakeholders in reporting as well as in action. Yeah, that's it from my side. I think we can go to questions. So Anandan, if any questions are there for Dillon.
So far we haven't received any questions from the participants. Maybe we can, if they have any questions, they can ask directly to Dillon or to Nikhil. Yeah, you can just click on the icon, raise the hand, so we can unmute you. You can speak to the speakers.
Yeah, Anandan, I see a hand raised by Juvi.
Juvi, yes, Juvi from Philippines. So Juvi, you're self-muted. Please unmute. You can ask your question. Juvi, can you hear us? Okay, maybe she is not able to unmute.
Okay, maybe, yeah, in the interest of time, possibly we can just have one last question, and we can then move to the closing. So, yeah, possibly, Dr. Saraf, if based on the Kochi case and also Nagpur, so what's your take on these efforts, and how do you think these cities would need to scale up efforts? Also, any gaps that you feel need to be addressed from a long-term perspective? Thank you.
So it's good that things are happening at the city level now more than what was happening a couple of years ago, and that Kochi and Nagpur are kind of leading the way on this. I wanted to know what is the buy-in from the urban local bodies in these two cities to kind of support this initiative over a longer period beyond the project. So if you can just tell us something about that. Do you think that once your organizations kind of finish the project, are they willing to continue this? And if yes, are they engaging in some kind of capacity building exercise simultaneously?
Sure. Yeah, Dillon, would you like to take that first, and then I can come in?
Yeah, sure. Thanks, Miguel. On your question, Saket, so you have already mentioned it. No, so it's not. So while KMC was our partner in this work, helping us to get access to data, identifying agencies at the city level, which can uh, sustain benchmarking efforts is challenging since no such mandates exist. You have already mentioned this. So the couple of entry points could be the utility doing this activity as a part of its demand side management, KCB. KCB has got demand side management programs running in Kerala. So that could be one entry point, which not the city administration, but the state level utility can take up this work and can go ahead with the work, or other state designated agencies like EMC, Energy Management Center, those state designated agencies also can take up this routinely in different cities within the state and designing target programs. So this is the kind of understanding that we have right now. And again, you have mentioned it again. So this will help us to. So this is just a beginning. We have initiated something in Kochi, and this will aid as a framework which the city can use later whenever such related work is going to come up. So when such an opportunity comes up at a later stage, the city will be prepared enough to take up that opportunity as well.
Thank you.
Yeah, thanks for the question, Dr. Saket. I think for Nagpur, yeah, so this activity and the building type was identified with the city agencies, and especially the smart city SPV of the city. They were engaged throughout. So they actually helped in this exercise. They got engaged. Hands-on engagement was there. They went with that with partners team in terms of meeting stakeholders, getting information on ground, and they are keen to do this continually for the public buildings from prioritization point of view, so that they can make allocations in the budgets for retrofits and so on, and also with the hotels. So they have been talking to the hotel association, engaging with them, so that this also becomes sort of a reporting exercise and also a continuous mode of engagement. So in those terms, there was keen interest from the city, from the top level as well, and not only to initiate but also to take this on. And yeah, capacity building some did happen through the process, and yeah, we hope that it also continues going forward. Thank you.
Thank you.
Yeah, I think in the interest of time, we will move to closing now. Sorry for questions that we could not take. Maybe you can type in your questions and we can take this up and reach out post-webinar. Over to you, Anand.
Sure. Thank you, Nikhil. And also, if you have any experiences in benchmarking carried out in your cities or country or in your projects, please feel free to share with us, also with other COP members. So next slide, please, Ritvik. Okay, just a quick update about this BE COP activities. So far, the work plan has been drafted until September 2020, and including today's session, 4 webinars have been completed, and a case study is being developed based on energy benchmarking and auditing carried out in Nagpur city, India. And once it's developed, it will be shared with COP members and ALP members. And through the COP, we will continue to share tools, resources, and other materials based on members' need. If there are any requirements, kindly forward it to us. And also, we would like to insist that the no-cost technical assistance can be supported through the communities of practice with the support from various technical partners we are associated with through this BE communities of practice. As the time and opportunity is limited, we really encourage you to make use of it. And at the end of September, based on members' feedback needs and of course with based on resource availability, future course of works will be decided and communicated to the COP members. Next slide, please, Ritvik. Yeah, and we take this opportunity to thank all the participants for being there till the end, and sorry to for the extension. And a very big thank you for all the speakers for the insightful presentations and your time. The presentations and recording will be posted in ALP website and also will be shared in email. You could please share it with your peers.
Hello. Hello. Yeah, Anandan, I'm not sure if you're audible. Thank you once again. And yeah, we look forward to future interactions. Thank you.
Right. Thanks, everyone. Bye.
Thank you.